Sweet. I see thumbs up. I see a check mark. Thank you. Perfect. All right, so what I'm going to do first is just kind of overview Gameboard. If you did not attend our product session on Gameboard, I do highly recommend checking it out. That's a deeper dive into Gameboard. But for now, I will just kind of give you an overview of Gameboard. So Gameboard is one of AirDK's features that helps you find playable areas in the environment, and it gives you an easy interface for creating 3 different key features, one of which is smart object placement. Sorry, the video didn't move. There we go. Smart object placement so that you can accurately place objects in the playable environment, character navigation to navigate your character around the AR environment, and to allow for procedural gameplay in this AR environment. In normal game design, you would exactly know how your map looks, so you can design gameplay related to that. But in AR, your map is growing as you move around the environment. So Gameboard helps you map their playable areas so that you can create a procedural gameplay experience. An important aspect of AR is to ensure that your experience behaves in a believable way, which will keep the user tuned into that experience. So if your objects behave in an unbelievable way, such as the Yeti's walking halfway throughout the ground, that'll detract from your app's experience. So Gameboard helps with making a believable navigation mesh in an AR space. So how does this work? So the ARDK already comes with meshing. So Gameboard takes advantage of this by using raycasting to estimate flat surfaces in the mesh. So we'll try to connect those flat surfaces via a tiled grid, and different surfaces themselves will be grouped together by elevation. So Gameboard is creating a navigation mesh in AR, and the mesh is constantly growing, as you can see in the video here. As you walk around the environment, we understand more about it, and we're able to denote the flat surfaces that you can work off of. So as a quick warm up, just to kind of get an idea about the audience here, I'd like to know why are you here, and what kind of hopes do you have for Lightship Gameboard? What kind of things do you want to make for Gameboard? What are you hoping to get out of this workshop? Just whoever is able to speak, definitely, I'd love to hear if you can unmute and say something or type in the chat. Just curious. And Chanel, I actually lost the chat. So if you could read it to me.
Yeah, no worries. Yeah. Tim said here to learn more about this and Gameboard in general. Awesome. Would be curious to know, like, what do you guys hope to do with Gameboard, especially some game developers in here, like Martin, you said that you're a game developer. Like, what are you hoping to learn from the session?
Yeah, so I suppose I can answer that. So we do a lot of work we do a lot of AR solutions for many different things, whether it be games or different projects, as I'm sure you've spoken to my colleagues about this. But yeah, so I think Gameboard actually provides you an opportunity to create something that is more interactive in a smaller 3D space. I feel like up till now, a lot of what we've been doing with the ARDK programs have been, I guess, more of an outdoor environment, and I guess more static placed or objects placed through a static method, where they are pretty much globally positioned and have a very strict set of attributes to them. I think that Gameboard is going to help and provide us with a great tool to be able to, I guess, do things in a more dynamic manner, and pretty much give us more of opportunities to do things that way.
For sure, I think Gameboard will help a ton there, so that you can have dynamic gameplay experiences no matter where the user is. They don't have to be in a perfectly square, flat room for it.
Yeah, and I don't think anyone answered, but maybe we can ask this again at the end after they built something, see if their minds change. Orion said, I'd like to make a hockey game or something like that, users being able to throw an object back and forth. Very cool.
Nice.
I'll be biased because I work at Niantic, but I'll say that when I first heard about Gameboard, I think that pathfinding in games is something that is comes up time and time again. So in the AR space, pathfinding, like Jamika said, your world or like your map is always changing and always getting bigger. So that from a performance perspective becomes almost impossible to handle. So having a feature that basically handles that for me in an efficient way with like real world mesh, I think is super powerful and just makes your life easier. So there's mine.
Awesome.
Dakota said, I've been interested in using it for enemy logic. I can see it being an interesting way to control aggro or something similar.
Cool, yeah, and with Gameboard, you can essentially help with AI. The enemies can navigate anywhere along that game board, and they'll, if you have a chair in the way, they'll walk around the chair, they'll jump over the chair, whatever it is you want them to do. So it could be a fun experience to try to put obstacles in the way of the enemy so that you can keep them away from you. I think there's a lot of cool gameplay aspects you can use for a game board.
I think a lot of mobile games too use like the tile based, like how far away are you from the enemy? They can only attack you if they're like one tile away. So if you had a tile based game like that, I could see Gameboard really helping with that.
Sure. Tower defense game could be fun. Yeah, I got my chat now and then I lost another screen, but it's okay. Don't need that screen. Gosh, I do love tower defense games. These are great ideas. I come from a gaming background. I love games. I love seeing people create cool games. I love playing their cool games. So definitely keep these ideas coming. I think they're great. And hopefully at the end of the workshop, you can have a basis or at least some inspiration for ways to bring these games to life. So looking forward to it. Cool. How about we proceed? We'll get into the workshop portion. So this is an overview of what we're going to do. This workshop is geared towards people that have pretty much zero ARDK experience and maybe very little Unity experience. So we are going to start slow and start with the basics on actually getting Lightship working in our environment. And then unfortunately, we can't all just deploy this to our phones and walk outside and play Gameboard over there. So we're going to actually test this experience in the Unity editor with a prefab mesh that I'll be providing to you guys. This is a mesh that's actually pulled from the geospatial browser on lightship.dev, which is in beta with the remote authoring feature of VPS. So this is it's a real world environment that I grabbed the mesh off of online that we're going to all test together. But I highly encourage you all to get these apps deployed to your phone and then go outside, go in your house, go wherever you want to see Gameboard working in real time. So we're going to test this experience in the Unity editor. And then after we have our Yeti able to navigate in this area, we'll have a little coin spotting mini game where you can tell the Yeti to go to the coins as they spawn in the environment. So to get started, we have a few prerequisites. Hopefully you already have Unity installed. If not, get that started right now. It's going to take some time. I'd highly recommend using Unity 2020 or 2021. I don't think you should use 2022 just yet, but if you have it, let's see how it goes. Make sure you have the latest version of AirDK downloaded over on lightship.dev. And Chanel just posted into the chat a link for the mesh prefab and some starter scripts that we'll be using for this workshop. Please get that downloaded. It's about 20 megabytes, I believe. It shouldn't take very long. And we will be looking at some code, so you will need to have some sort of IDE installed on your computer. All right, so I know this is going to probably take a moment for you guys to get everything downloaded and open. So when you're all ready, please give me a green check mark in the chat, or in the reaction rather, and then we can get started.
I think we are good.
There we go. Trying to get these check marks. Thank you, Braxton. He posted in the chat the download for AirDK if you don't have it already. If you're on an older version, it's probably fine as long as you're on something newer than if you're on 2.0 and higher. I highly recommend getting 2.3. If you have a project that you want to work off of that's 2.2, it's fine. Don't worry about it. But let's get started. So first we're going to set up Lightship. If you've never done this before, it's fairly easy, but we'll go through it step by step. What you're going to want to do first is actually create a Lightship API key. This is a best practice for all Lightship applications. So you'll want to go to the dashboard and create a new project if you have not yet done so. And then in the new project, you want to create a new key and then copy that key into the clipboard for later. We'll be putting it into Unity when we're ready for it. And as Braxton posted already, make sure you have AirDK downloaded. We'll be using the latest version, which is 2.3. So get that download started. And as Chanel posted, there is a custom Unity package that we just distributed that contains the prefabs and some scripts for this project. So to repeat again, make sure we create a Lightship project on lightship.dev so that we can generate an API key. We'll want to download AirDK. The latest version is 2.3. And then we'll also want to download the custom workshop package that Chanel posted into the chat. And so when we're good here, I think all these check marks were still there from last time. So give you a moment to maybe unset or reset your check marks, and then we'll proceed. It's looking pretty good so far. All right, so this is more setting up Lightship. So if you have AirDK experience, this is easy peasy for you. If not, don't worry, we're going through it step by step. So first in Unity, we're going to want to create a new project. Set this one as 3D mobile, even though we won't be deploying this to device during this workshop, but once you want to deploy this afterwards, it'll just be easier if you have it set to 3D mobile right now. So create a new Unity project, call it whatever you want, and then we'll create, and afterwards, we're going to import the AirDK 2.3 version. And so I think Jamie joined just recently. Welcome. All we're doing right now is setting up AirDK. I believe, yes, Chanel posted into the chat the custom file that we're going to need to work off of with the prefabs we'll be using for this project and some scripts that we'll be using for this project. So what we're doing right now is creating a new Unity project. We're going to import the AirDK 2.3 package that we downloaded from lightship.dev. And then as you probably guessed it, we are going to import the custom workshop package that was just distributed in chat. And so once we have those things imported, we're going to set our API key over into the AirDK auth config that is found in the assets/resources/AirDK folder. This was imported with the custom package to just make it easier on you for importing your API key. If you've done projects on your own, you probably are familiar with this step where you have to make your own AirDK auth config file. Here it is for you to just make it a little bit easier. And so once we have that, if everybody, once they're ready, could put check marks into the reaction so that we can move forward. And this is all just AirDK setup. So if you've done this before, it's easy peasy. If you've not done it before, this is just getting everything imported, getting our keys in there so that we're ready to go. I think this is pretty good collection. And if you have any issues, feel free to type them in chat. And if you have any questions, we have a Slido that Braxton will be answering questions in there. But definitely if something comes up, please just let us know. Cool. Actually, at this moment, let's take a slightly longer break because I'm going to open up my Unity so that I can work alongside with you all. So give me a moment. Here and here, share. All right, Chanel Braxton, gonna get a thumbs up if you see it.
Looks good.
Neat. All right, so I have Unity on the right and our slides on the left. So this is important for working with Gameboard in particular. What we want to do first is create a new layer in Unity called AirDK underscore Gameboard. This is the layer that all the raycasting is going to be happening on for the Gameboard experience. So to set up our Gameboard experience in the Unity editor, we're going to want to create a new AirDK Gameboard layer. So there's a couple ways to do this in Unity, but one way you can do it is at the top, go to Edit and then Project Settings. Oops, sorry, this is Zoom's edit. There we go. Edit Project Settings, and then a new window should open up, which might not be showing up for Zoom, I just realized. A new section called Tags and Layers. You can see in the slides what it looks like. And then we'll just add a new user layer called AirDK Gameboard. So if you could not find it in the edit section, once again, it's edit, project settings, and then go to tags and layers. In the Unity editor itself, you can also on the top right side of the screen, you can see all the layers that we have. You can also edit layers here and just add AirDK Gameboard. But we'll want to make sure that we have this Gameboard layer so that we can test within the Unity editor. Cool. And so we're now going to be able to test in the Unity editor, we're going to add our mesh prefab into the scene. So under assets, there's a folder called prefabs that has a collection of the prefabs we'll be using. In the mesh folder, I have a waste spot mesh. It's called Big Heart on the Rock. It doesn't matter what it is, it's just a mesh. We'll drag and drop this into our hierarchy view on the left to put this mesh into our scene. And then in Unity, you'll want to make sure that in the inspector, so make sure you have the in the hierarchy view, have the Big Heart on the Rock selected so that it shows up on the inspector on the right. And then on the top right over here, make sure the layer is set to AirDK Gameboard. This will be the layer that we actually perform raycasting on. And in the future, if you choose to use your own meshes to test within the Unity editor, make sure that you also have a mesh collider on this mesh so that there is a surface that we can actually place our Yeti onto. So checkpoint, how are we doing? I'll go back to this slide because this is probably one of the more important slides. We're going to make sure in our mesh that we have the layer at the top right set to the AirDK Gameboard layer that we just created. And just double check and be aware that the mesh does have a mesh collider attached to it. I see. Okay, I see check marks coming back. Cool, that's good. Great. All right, let's keep going. Now this is some setup. This isn't Gameboard specific. This is AirDK specific. We're going to add the AR Scene Manager into our project. This will handle the setting up AirDK. So in the project view down here, we can search for the AR Scene Manager and then just drag and drop this prefab into our hierarchy view to put it into our scene. So we're adding the AR Scene Manager into our scene, and this will handle initializing AirDK and the AR camera. And so because the AR Scene Manager already comes with the camera, if I expand it here, we see it comes with an AR Scene camera. We're going to want to delete the main camera that came with the scene by default. Just right click, delete. Don't care about it. We only want one camera here. So we deleted our main camera. Should be good. All we did was add our AR Scene Manager and then deleted the main camera. So we are at a good spot to start AirDK. Give it a moment. All right, looking good. Now we're going to want to create a Gameboard Manager object into our scene. This will handle our Gameboard specific scripts. So in the hierarchy view, let's create an empty game object and just call it Gameboard Manager. This name doesn't quite matter, but let's all call it Game Manager for consistency. And then after we've created that Gameboard Manager, we're going to want to attach AirDK's Gameboard Manager script. So make sure that the Gameboard Manager is selected on the hierarchy view. And then on the right side in the inspector, we'll want to click Add Component and then just search for Gameboard Manager. You'll see that there's also the Workshop Gameboard Manager. We will be adding that, but right now we're adding the Gameboard Manager itself. This is AirDK's Gameboard Manager. This is all the logic of AirDK's Gameboard that we're going to be putting into our scene. So after we've created our we created a game object called a Gameboard Manager. We attach the Gameboard Manager script to it. We're going to actually not edit the script, but we're going to set a few things. So you'll see that the camera is not set. We're going to want to set that to our AR scene camera. And the layer mask, this part's important. We're going to want to change the layer mask to the AirDK Gameboard layer that we created a few steps ago. So one way you could do it, you can unclick everything else and then Gameboard, or click nothing and then Gameboard. Just make sure that in the end, AirDK Gameboard is the object that's selected here. And I would leave everything else as defaults for this experience. And now similarly, we're going to add our workshop logic to this object. So make sure that the Gameboard Manager is still selected on the left side. So we're in the inspector view on the right for it. And now search for the Workshop Gameboard Manager script and attach that to the Gameboard Manager. And this will be the script that we're going to be working off of for this experience. And as you might have guessed, we're just going to make sure we fill these out with the AR camera. So the AR scene camera that we had from the AR scene manager will be our AR camera. And the agent prefab, this will be the prefab that's actually being spawned and is going to walk around in our environment. It's going to, in this instance, we have a Yeti prefab that you can use. So you can either search for it or drag and drop it, however you want to do, but the Yeti asset is located in the prefab/Yeti folder. And then one more step before we do a quick test. So back into that, in that prefabs Yeti folder, you'll want to click on the Yeti prefab. We're not going to actually drag it into the inspector or into the hierarchy. It's going to spawn via code, so don't worry about that. But we want to attach some logic to it so that it can actually navigate on the game board. So make sure we click on the Yeti prefab that's within the folder. We're not dragging it into the hierarchy view. And then click Add Component here to then add the Workshop Gameboard, Workshop Gameboard Agent script. And so this Yeti will have the Workshop Gameboard Agent script that we attached to it. We'll be taking a look at that soon, but for right now, we're just attaching the script to it. And this is a mini checkpoint, but we're going to then try playing this in Unity, and afterwards, let's see. So we click play, we should have everything set up at the moment, and we will see the game board being generated in the scene, but we're not going to actually be able to do anything because we haven't coded beyond starting game board and AirDK. So whoops, I cheated. Sorry, I did code the rest of it, but pretend you didn't see that part. As we walk around this space, the game board is generating or creating more and more tiles as I walk around. And it does look like, let's see, say on this instance, it looks as if the tile is not being generated on this mesh, but it's just because there's a slight mesh on this, a slight bump in the mesh. The game board is kind of estimating the average height of everything right here. So we will be able to navigate on that space. If I look over to the scene view here, we can see overall what the game board is generating in this scene. So, all right, so just to double check, how is everybody doing? Is everybody able to generate the game board tiles on the scene? Getting couple check marks, looking good. We have a short break built in right here, so don't like stress about it. Let's get this working right now. We're gonna make sure everybody's caught up to speed, and then we'll keep going. So if you have any questions, please ask them in the Slido. If anything just comes up, I mean, I'm here. I will, for convenience sake, it's sometimes helpful to have the scene and the game views separate. So I'll show you all how, or you could see in the scene how the game board is being generated as I navigate this space. I wish I had like a joystick or something to more naturally walk this plane, but you know, it's just the Unity editor, so it is.
Is this
Make it,
on right now, Jamika? Or
say that again?
are we on break yet?
We're on break. We're on break. I'm just talking through break.
I think someone joined late. If you want to raise your hand, if you're not caught up, feel free to use the raise hand feature and we'll get you caught up. Let's see. No one, maybe they just want to listen in.
All good, all good.
Okay.
So if we have all these steps done, the result on the right, or on the right is the state we should be at. We shouldn't be able to click and spawn the Yeti. We could just create our game board experience right now. So let people catch up, let people take a moment, and then we will continue. And as a suggestion to kind of see game board being made at once, all I did was grab my game view and put it side by side next to my scene view in Unity, but it's not necessary for you to do. But if you did join late, don't worry about it. I mean, feel free to ask questions in Slido. If you're able to catch up because you have some AirDK experience, that's great too. If you're falling behind, that's all right. We'll have breakout rooms at the end if you wanted to have some more one-on-one assistance in getting caught up. It'll be pretty straightforward, don't worry about it. So if you just want to follow along for now, that's all right as well. Probably, I think, one more minute, Chanel, and then we'll move forward.
Yeah, I think everyone is caught up who's building along with us.
Cool, cool. Alrighty, let me unplay so that my changes actually stick that I do in Unity. All right, and so as we progress, there we go, there we go. Okay, slides are good. We're actually now going to start looking at some code. So what we're going to want to do right now is open the workshop Gameboard Manager script. So in the assets/scripts folder, we have a few scripts that we'll be using. The first one we're going to be looking at is the workshop Gameboard Manager script. And we'll open this in our IDE of choice. So if you double click it, it should open into whatever you have as default for Unity. And so once you have that open, you'll see that the code is pretty much all there, but we have commented out the functions that we're going to be walking through step by step. So you don't have to actually copy anything from the slides, furiously type them into the IDE. We're just going to be going over together the different functions that we're going to be using for this experience. So if we focus first on the global variables that we have, the most important ones here, I mean, we have our AR camera, we have the prefab that's going to be spawning our Yeti, but the game board object is going to handle our smart placement. It's going to be what we're going to use to see where we can navigate. This will be creating the path for us when we want to move our Yeti around. The most important thing we have here is that game board global variable. So first, the next 4 or so functions are just going to be set up for AirDK and Gameboard. You've done this before if you've done AirDK, nothing fancy. On enable, we're going to register our session or our event handler for on session initialized. And then as best practices for on disable, we will deregister our on session initialized event handler and then destroy our Yeti sounds pretty awful, but destroy our game object. There we go. And then set that to null, just standard cleanup that we'll be doing. And then within on session initialized itself, we'll want to make sure that the AR session is valid, we'll want to set our AR session to the result of the arguments. So we'll be given an AR session that we'll be setting here. And then once our AR session has started, we'll want to register our on game board created event handler. So more setup. This isn't any of the fun logic. This is just setup that we have to do. In the on game board created event handler, we will register the game board result in our game board global variable. And then as more best practices and cleanup, we're going to have our on game board destroyed event handler registered as well. So as you can probably guess, for on game board destroyed, it's just nullify the game board global variable. We don't want to use it in this case. But for the workshop, everything's going to be valid. We're not actually destroying things or stopping the scene. This is just, if you're going to take this project and build on top of it, these are some things you're going to have in your code. And soon we will see how honestly easy AirDK makes Gameboard. We'll see some of the functions that Gameboard will handle for us so that we can focus on gameplay logic, not trying to figure out how to create a navigation mesh off of a dynamically growing AR mesh. So in our update function, what we're going to do for this experience is detect the touches and place our Yeti on valid spaces on the mesh. So in update, if our game board is null, we messed up our setup somewhere, so don't process a touch. But otherwise, if we try to get the active touch, we want to then call on touch screen with our touch. So this is basic. So if our game board's not valid, don't do anything. If it is valid and we got a touch, let's process the touch. So then, sorry, I should slow down a tiny bit, but we had all our setup done. The update function is where the actual logic starts to start. And so if the game board is valid and we have a touch, we're moving on to on touch screen. So just some more checks to see if we need an early return. If our AR session is null or our camera is null for whatever reason, we're not going to process this. And so we're going to actually use raycasting to detect where we can place our Yeti into the scene. So we have our mesh that we have imported into Unity. We set it to the AirDK Gameboard layer, and our raycasts are going to be looking at objects in that AirDK Gameboard layer. And so we're going to, if our Yeti doesn't exist, we're going to actually spawn our Yeti in that spot. If the Yeti does exist, then we're going to try to move the Yeti to that spot. So the first thing we're going to fill out is the spawn agent. So under the spawn agent function, we're going to instantiate our Yeti prefab and then move its position to where we placed it, or where the result of our raycast. And we're going to rotate him such that he's facing towards the camera as opposed to some random old direction. And for the agent itself, we have a slight state machine built into the workshop Gameboard agent to tell us that he is not currently moving. So we're going to set his state to idle. This state machine just helps us determine if the Yeti is currently moving or if the Yeti is not moving and is ready to be moved somewhere. So this is just for spawning the Yeti onto the screen. And now we're going to go to a different script. We're going to now go back to Unity, go to the scripts folder, and then open up the workshop Gameboard agent script that we were just speaking about that has the state machine. It has logic for actually moving the Yeti. Those are all very Unity specific logic. So I feel free at your own time to dive into those to see how they work, but we're going to be focusing on the Gameboard logic in these scripts. So within the workshop Gameboard agent script that we've opened up, we're going to Control F to look for the set destination function. And this is the logic that then determines how we will move our Yeti across this space. So one key function I want to call out is the Gameboard.find nearest free position. This takes in a vector 3 for the current position that we're at, and then gives you a vector 3 for a position, well, the nearest free position on the game board that the Yeti can move to. And so we're then going to use the next line down, the bool result, the Gameboard.calculate_path. This is the path finding logic that Gameboard will just handle for you. So calculate path will take the position you want to start at, which you found from the find nearest free position. That's where the Yeti is, or that's right next to the Yeti. The destination where we want to go, which is the click that we did on the screen. Some configs for the Yeti, such as the pathfinding logic it wants to take. Does it want to prioritize the shortest path? Is it okay with jumping across obstacles to get to the shortest path? And then the path itself, which is a list of different waypoints that the Yeti will need to hit as it walks across the game board. Okay, I know that's a mouthful, but we're just giving the calculate path function where we are, where we want to go to, some basic configurations about the Yeti, and then it'll, if it has one, spits out a path to us. They will then use some code routines to actually navigate the Yeti to each waypoint until it gets to its destination. Whew, I know that was a mouthful, but this calculate path, the find nearest free position and calculate path are things that AirDK is handling for us, so that all we need to do is actually worry about moving our object in however way we want to from point A to each little point along the way until we get to point B. Cool. All right, so we're going to actually test this in the Unity editor. Let me play the video. If everything is done correctly, I have a video on the left we'll see. Once we click play and kind of make a little bit of the game board known. So you have to imagine yourself walking up to this scene. Click somewhere to spawn our Yeti. And you could see that it will navigate in the spaces around us. And you can see in the video I have here. Sorry, I'll play the video and then actually do it on the right side. You could see that the tiles are being generated below the step and also above the step. These are different elevation planes of the game board that we can detect. And so the Yeti is actually able to traverse across these different elevation planes based off of one of the settings that says it's okay to traverse planes that are this high. These are things you can customize with the game board as you'd like. Neat. This is a slight check mark because I know that we went through a lot just now. So please either write in the Slido if you have any issues, ask questions, put a check mark if you are able to have your Yeti spawn in the environment on the first click, and then on the second click, actually navigate to another spot in the game board. Correct. Thank you, Braxton. You can use the WASD keys to actually move the camera around in the play mode. Let me actually show that to you here. It's a little awkward. I understand. That's just a Unity thing. If you're, held your phone, you're walking around at the park, it would definitely feel a lot more natural. So I'm walking around this space. Gosh, WASD is not the most comfortable, but it's what we got in the Unity editor. And then I click on a spot and it will spawn our Yeti. And then if I click on another spot, the Yeti will slowly walk to another location. We can actually change the Yeti's speed in, I believe, the Gameboard Manager. No. The Yeti, the spawned Yeti clone here, you can see, you can change the walking speed to 5, 10. 10 is very fast. You can change it if you cannot stand how slow the Yeti is walking at the moment. Which variable / method triggers the plane switching animation? Nothing triggers the plane switching, or maybe I'm misunderstanding, but the game board is detecting all of the flat surfaces as we walk around the mesh. Oops, I cannot click. I can't click without the Yeti moving too. The game board is detecting all the flat surfaces on the mesh. And so it sees there's a flat surface up here. It sees a flat surface down here. And our Yeti, our pathfinding is telling it wants to go from A to B. They are on 2 different elevations. And so we just have some logic in the game board workshop agent that will jump across these different planes, or just jump across these different way spots. And to just sort of show off a little bit, where are you? The big heart on the rock. If I just hide the mesh right now, we can see on the scene view all of our understanding of flat surfaces in this mesh. And these are all spots that the Yeti can navigate to. If I were to click on a spot the Yeti can't reach, it'll get as far as possible to that spot before just stopping. So if I click, well, that's not even on the mesh. It'll get as far as it can in this scene. So all I did to make it look like this on the right, I just hid the mesh renderer so that we could see everything that we understand to be flat in this prefab that we imported. And oh, go ahead.
I was just going to say, while we're on break here and covering some topics, there was a question in the Slido that we can show in Unity pretty easily here. A question that came through is how large are the generated tiles? And if you go to the Gameboard Manager, which is an object in the hierarchy, there is a Gameboard Manager script component attached to it, and there's a tile size property there. And for our demo, looks like that's set to 0.15. But that's where you can set the size of the tiles. And my understanding is those are metric units. So if you set that to 1, it would be like 1 meter sized tiles. But that's where that's at.
Yep. Thank you, Braxton. We're currently just in break time. I'm just going to try to discover as much of this mesh as possible. I really wish I had like a joystick. As somebody that likes playing games, this is so uncomfortable. Unity, I don't like this, but this is a great way to be able to test without having to actually go out into this space. And I can quickly iterate on my design here, test the new feature, and then take that out to the park, to the big heart on the rock, wherever it is I want to go. And coming soon, more people will be able to use the video playback feature so that you can actually record an AR session of you walking to the park, walking to this this big heart on a rock, recording that, and then using that recording in the Unity editor with Gameboard attached to it as well. So moving forward, that'll be a much better way to test within the Unity editor, because it is actually the real world just in a recording, as opposed to here's a mesh prefab that I just spat into the Unity editor. So we'll give it a couple minutes. If anyone wants me to show something in particular, I am happy to do that, or else I'll just keep playing around moving the Yeti. I do enjoy this kind of thing. I love games. I love being able to use AR with games. Even though this is really simple, it's moving a Yeti in a, well, real/virtual space. I feel like there's a lot of cool games like we were brainstorming with earlier, tower defense, hiding from the enemies, trying to hide from their aggro sight lines, whatever it is that you want to do. Or even just a virtual pet, just have the have the Yeti walk alongside you in the AR space, whatever it is you want to do. There's a lot you can do, because Gameboard does the difficult part of pathfinding, does a difficult part of figuring out the navigation mesh all for you. All you need to do is apply your logic to move the object across that navigation mesh. So we'll give this a couple more minutes. Oh, Ryan says he's super interested in the video recording aspect. Cute art is what first interested you in AR. I don't know what a cute art is. I don't know. Braxton, are you familiar with the cute art? Can somebody educate me here?
I have not.
That sounds neat. I think Ryan had said that they're in a allowed space so that they can't come off on cam and speak with us. But okay, it's like an art gallery in your phone. Ooh, that could be really interesting.
A quick Google looks like some pretty awesome stuff.
Nice. I want to re-show while we're in this little break how you can hide the mesh so you can just see the game board as a whole. If we go to the big heart on a rock on the hierarchy view on the right side in the inspector, you just uncheck the mesh renderer, and then we can see in the scene view the entire game board as is. So the Yeti can walk in anywhere on these green paths. And this wireframe kind of look, that's the physical, the mesh collider, so that we have physics applied to this mesh. We'll give it until the hour, and then we will do our last feature, which is going to be adding procedural gameplay to the scene, which will be our coin spawner. I just love seeing the Yeti jump. I just love this little hop. I love that it can navigate across these different spaces. It's adorable to me, just the hop. Anyway, I'm just having fun during break. Now that we are going to proceed, go Dodie, it's so cute. Anyway, last step, or last, well, couple steps, but Last feature is adding procedural gameplay. This is where we will be spawning the coin in the scene. So let me unplay so that my changes actually stick. We're going to create the coin generator game object into the scene. So similarly to how we created the Gameboard Manager, we're going to create an empty object and name this one coin generator. This one, it does matter what you call it. So just call it the coin generator here. And here on our coin generator game object, we're going to add a new component, and we're going to add the coin generator script that came with us in the scripts folder. And as you might guess, we want to make sure that this coin prefab is filled out. So we'll click this, and I believe the asset is just called coin. Add this into the scene. I recommend leaving the defaults as you'd like, but if you'd like to change the coin size, if you want the coin to spawn further away from the Yeti, or you want the arena to be bigger before you can spawn coins, you can feel free to adjust those things. But for now, I just recommend leaving the defaults. And now we actually have to add logic to the Yeti itself so that the Yeti can actually collect these coins. So we'll go back to the prefabs folder and then to Yeti and click on the Yeti. Remember, it's not actually in our hierarchy view because this will be instantiated programmatically. And so in this Yeti, we are going to add the collect coin script. So we'll click add component, collect coin. And we're not actually going to edit this script. It's very basic. I will go over the contents of it. So if you take a look at the screen here, or you can open it up if you'd like. This will, once the Yeti is instantiated into the scene, it will look for a coin generator and then actually create a new coin on the game board. And so once it's created a new coin, as you move your Yeti and the Yeti's capsule collider, so the Yeti's collider, if it intersects with the coin itself, we'll destroy it. So, you know, we collected the coin. We'll just print a log saying we collected the coin and then generate a new coin. This is all collect coin does. It spawns the coin, and if the Yeti intersects with it, destroy it and spawn a new coin. So we're not going to actually go into that any more than that. So how are we? We got our Yetis, has the collect coin script attached to it. We have our coin generator game object, and coin generator has the coin generator script attached to it. How are we doing? Check marks. No one ever uses the red X, so it's okay. My feelings won't be hurt. You could say, hold on, give me more time. Neat. Maybe, no, I think we're good. I think everyone following along is up to date. And now we are going to actually open the coin generator script. It's another simple one. But it's going to be using a key feature of Gameboard. So go to scripts and then double click the coin generator so that we can open this one in our IDE of choice. And the only function in here that we not truly care about, but the function that we're going to be looking at is the update function here. Everything else is just kind of set up for this experience. Creating a new coin, I mean, it spawns the coin in the space, but update is what we care about here. So first, is our game board area at least the minimum discovered area that we want to have this experience in? So we can use gameboard.area to understand kind of the amount of the tiles that we have in this area. If that's true, then we'll actually use the game board to give us a random position in this space. So we have where we're currently at, and we're actually giving it a search radius that it can go out to. And then it will give us a vector 3 on the the random position that says like, hey, this is a random position based off of those parameters you gave me on the game board. And then some personal logic is this spawn point at least our minimum distance away from our current position. It's not a very fun game if the game board gave us something that's the tile to our right. So we'll just make sure this is at least a little bit far away. And is the coin that we want to spawn, is it big enough to fit on the game board? So let's say we have, coins are very small, but maybe we have a massive rock or whatever it is we want to spawn in the scene. Will it fit in our arena for our understanding of the game board? So the game board has a function called check fit to see if for this position, will the coin size fit here? And if all of this is true, we will instantiate the coin prefab in this space. So game board helped us find a random position. First, game board told us how big our game board area is. Then it helped us find a random position. And then it helped us see, can we even fit the coin here? And so by default, all these things are yes, because we made it that way. But these functions will help you determine if you can place these objects in this current path, or not path, in this area. So with all of that, we should be good to actually go back to Unity, press play, and first create a small enough or smaller, big enough area for this experience to happen in. Spawn our Yeti, and then immediately a coin should spawn nearby. And then we'll want to navigate our Yeti to that location. So if you purposely don't scan all of that area, the Yeti will still find a path to that coin because we made sure that it is a spot in the game board that the Yeti can navigate to. But if you go and you fine tune and make sure you have all of this mesh navigated, then the Yeti will likely take the shortest path from A to B to that coin. So let me play it over here on the right as well. Give Unity a moment. Use WASD to move around. Spawn my Dodie. Here's my coin. I think there it is. I didn't navigate around here, so the Yeti doesn't actually know that's a spot it could go. Got it. Sorry, it's not that interesting of a game, but I'm acting like it's a real game. Sorry, I just like having fun. But how are we here? That is the last feature that we're adding. Check marks, we good. We have our Yeti spawning into the scene. We have our coins spawning as well. We're able to navigate to the coin. Yeti, if a coin, let me see if I can trigger it. If a coin spawns on the other side of the heart, will I see the Yeti walk around it or go across? This one, the Yeti will probably jump up, yeah. But the great part is I didn't have to worry about the path finding. I just told it, take the shortest path. I don't want to calculate that myself. Cool. I think we have like all check marks. That's it, guys and gals and everybody. That's the game board workshop. Thank you all for sticking with this and getting your your Yeti spawned on the screen. So the things that we learned were the slides. Hello, there we go. Being able to place our objects onto the game board. We have our pathfinding in the AR space. So the game board helps us dynamically pathfind as our mesh grows. And we had a little element of procedural gameplay where based off of our knowledge of the game board, we'll randomly spawn a coin to that position, collect it, spawn a new coin. So as some next steps, I highly, highly, highly recommend getting this deployed onto your phone and playing this in your own space. It really adds a personal experience to it, and you can kind of see how it's working live on your device, how Gameboard is generating that mesh, and your Yeti is able to walk around that around your space, walk around obstacles in the space to be able to grab that coin. You can also expand upon the state machine that we already have started. So maybe add some logic for the Yeti to just explore the game board on its own. As I was saying earlier, maybe have the Yeti walk alongside you, because as you walk and you hold your phone out, it'll constantly generate more of the mesh, and therefore it'll generate more of the game board that the Yeti can walk around. So you can have the Yeti continuously walk alongside you, for example. And also combine the game board with other AirDK features such as game board and VPS. Maybe Yeti can walk between two different way spots in your way spots in your area. Maybe game board and shared AR, where you have a shared game board space and you can have an interactive experience with other users all on that game board. There's so many different things you could do with this, but I encourage you all to try combining game board with different AirDK features.